Speaker number 2 in this look at the oceans, what's happening in our EEZ, is a gentleman who's had 24 years of experience in resource management. Indeed, in the last century, in fact in the 1990s, he wrote the Hawke's Bay Regional Coastal Plan. In 2010, he managed coastal permit applications for AWE's Tuatara exploration well, just 20 kilometres off D'Urville Island, so he's had some practical experience in that regard, and has also over the years, on behalf of a number of private sector clients, secured approvals and undertaken marine mammal impact assessments for DOC and secured the approvals for his clients from DOC. Looking at the practical effects of the EEZ legislation, the Managing Director of Resource and Environmental Management, please welcome Craig Welsh.
Thank you, Jim. I'm going to discuss what the Act means in practice with respect to environmental management offshore based on my company's experience. We have lodged 3 impact assessments with the EPA this year for offshore petroleum drilling. 2 of those have been accepted as complete and 1 is being processed at the moment. I'm also going to look at what operators are doing anyway to achieve environmental outcomes and just briefly touch on the question about will the new legislation improve environmental outcomes, bearing in mind that I am going to focus my talk on offshore petroleum drilling. This is the Canteen 4. It's a semi-submersible rig and it's towed to site. It's ballasted and connected to the seabed with anchors, 2 anchors on each corner, 8 anchors in total. I won't dwell on that anymore because Patrick's going to talk more about that rig soon. When we're preparing an impact assessment, we need to understand the industry and their activities, terminology such as spud date and wildcat well. We're unable to take a site visit, which is unique in terms of land-based projects compared to sea-based projects. We do a desktop assessment of a range of existing information and identify the need for technical information and reports to fill any information gaps. Consultation is important. We put a lot of emphasis into that. The consultation is also undertaken in conjunction with the oil companies. Like the companies are well represented at those meetings. We liaise with the EPA, DOC and MNZ and prepare the impact assessment in accordance with Section 39 of the Act. The matters the impact assessment must address pretty much mirror what's in the Resource Management Act. However, there is a new term, existing interest, and economic benefits are assessed by the EPA, so we include those in the impact assessments. They're not listed in Section 39, but we cover them. There's 3 types of vessels used for offshore drilling: a jack-up rig, a drill ship, or a semi-submersible. I showed you the Canteen before, which is a semi-sub, and water depths greater than 110 metres. The companies generally use a floating rig. Less than that, they can use the jack-up rig. This is a picture of a jack-up rig. Typically have 3 legs for stability reasons. This is the ENSCO 107 parked outside and parked in Tasman Bay recently, just off Nelson City. The rigs provide a stable platform enabling drilling safely and sustainably. We consider a number of planned activities: the establishment of the rig on site, seabed disturbance from connecting to the sea floor, and occupation of space. There's also disturbance from the drilling and discharge of drill cuttings. This shows a basic mud circulation diagram. The mud is pumped down the drill pipe, and the muds and cuttings are returned to the rig. The cuttings are discharged into the sea, and the muds are reused. They go through a system on the rig and they're put back down the pipe to continue the drilling. We also consider discharge of cooling water, solid and liquid waste management, atmospheric emissions, borehole seismic surveys, plugging and abandoning the well, and removing the rig from the site. The wells are usually, the casings are trimmed below the seabed to prevent nets, etc., from getting caught on them. There's also unplanned activities, biosecurity incursion, oil or hazardous substance spill and collision. The description of the environment, the physical environment, biological and anthropogenic. We use a number of, I don't use. We employ contractors to use a number of different techniques. Van Veen grab there on the left-hand side, which grabs samples off the seabed of materials and fauna, and also remote operating video sleds are two examples of technical tools. With the effects from planned activities, we assess those against the activities against the component parts of the environment. This is where marine biologists and marine ecologists come to the forefront. I think there'll be a big demand for those skills over the next 10 years. Most effects from exploration drilling are relatively minor, subject to mitigation measures being in place, and I'll discuss those soon. Also, I'd like to add that the activities should be undertaken by skilled operators. The discharge of drill cuttings have the potential to smother the seabed and need to be carefully managed. They can also cause a notable plume. This is a basic diagram of discharging the drill cuttings. Some cuttings fall directly to the seabed and some are held in suspension before they settle. You can see the drill pipe and midway through the water column, the discharge pipe midway in the water column, and the cuttings coming out of it. The ones that settle on the seabed there, I'd just like to note that that mound is exaggerated for the scale of this image. A better image is this diagram, which shows the thickness of deposition with distance from the discharge location. The thickness contours in this slide are in millimetres, overlaid on a 250 metre radius. You can see that at 250 metres it's 0.1 millimetre thick. The contours, the colour on the contour map also indicates the thickness. So red is a deeper deposit. We're still talking about minor levels of deposition. This slide shows the potential of a spill to affect a number of different values. I won't dwell on that too long because most people are familiar with them. They get a lot of coverage in the press. I'll move on to measures to avoid, remedy and mitigate adverse effects. These include extensive planning, monitoring systems and safety measures. The oil companies put years of planning into these campaigns, and I'm sure Patrick will deal with that soon. The oil spill trajectory modelling, discharge management plans and response systems and equipment. Anti-fouling paint and rig inspections. The Biosecurity Act has been recently reviewed. It's introduced craft risk management standards, which are currently voluntary. They're coming into force probably in 2017. There's also monitoring systems to detect any hydrocarbon contamination of any discharged water. If it's above 15 parts per million, it is not discharged. Drilling fluids and muds, muds are used to balance the formation pressure in the well. This is a primary blowout prevention measure. The weight of the mud can hold the oil down in the reservoir if there's any chance of a blowout. There's also use of blowout preventer systems, which I'll talk about briefly soon. Casing the well, which is running a steel pipe progressively into completed sections of the well, and that's cemented in place prior to entering the reservoir to enable well pressure to be controlled. In other words, there's a closed loop from the rig to the reservoir. Sophisticated monitoring systems are used to detect potential blowouts, changes in pressure. There's improved backup systems, deposition modelling of drill cuttings and post-drilling monitoring. This is a schematic of a blowout preventer system attached to the well. It's a device attached to the well head that closes around the drill pipe or casing and seals off the well. The top left-hand segment of the slide shows the blowout preventer at the top of the well. In the middle section, you can see the rig connected to the blowout preventer by the drill string, and then the pipe going to the reservoir. Other measures include notice to mariners, which are issued and broadcast on marine radio, adherence to collision regulations to avoid collisions at sea, establishing a 500 metre non-interference zone, support vessels are anchored or positioned at all times within the operation area, correct navigation lighting is used, or should be used. Unnecessary lighting is shut off at night. This is to help mitigate seabirds becoming disorientated at night. The well is plugged and the casing is cut below the seabed and all structures are removed. The rig and supply vessels have sewage treatment systems on board and only biodegradable food waste is discharged. Drainage plugs are ducted to treatment systems on the rig and support vessels. In addition to that, oily residues are drained off into drums for shipment to shore and disposal at approved landfills. Engines and equipment are regularly serviced and maintained, and other mitigation measures are identified through consultation. These will be specific to each project and it's issue dependent. Consultation is important, who and when to consult. The breadth of consultation we undertake with this drilling is determined to a large extent by oil spill fate modelling. We consult early in the process but are cognizant of the need to avoid consultation overload. I think with the new legislation there'll be a number of companies going to the same parties to consult, and so we need to be wary of that. The consultation itinerary that we follow will be included in the impact assessment, and any written approvals that we obtain will also be included. What are operators doing anyway to achieve environmental outcomes? I'll outline a number of the measures above. These ensure compliance with a plethora of legislation and guidelines that already exist. I'll briefly flick onto those. I'm not going to go through those, but there's already a number of pieces of legislation in place, each of which addresses a little bit of effects on the environment.
15 minutes.
Very good. Companies are already adopting high standards in relation to environmental management. The stringent internal HSE requirements and extensive planning goes into these campaigns. Mitigation measures are built into the project design. Oil companies have a good track record in offshore Taranaki Basin. Will the new legislation improve environmental outcomes? From a drilling point of view, it's hard to say. It's early days. But there's been no notable environmental issues to date in the offshore Taranaki Basin. Maui A was built in 1979, which is 34 years ago, and offshore operations have increased since then. Large components of the project are fixed by practical requirements. These companies are operating in an offshore environment which is rough and unforgiving. There's also specialist equipment, big rigs and vessels, and specific drilling requirements. As I mentioned before, mitigation measures are already built into these projects. The companies are, in my opinion, from what I've seen, operating to high standards. The requisite monitoring that Rob mentioned across a wide range of matters will, I think, result in an improved understanding of the offshore environment. We don't know what we don't know. That's an interesting thing to say, but new issues may be uncovered that will require management, and I think the monitoring will assist with that. The new legislation ties together some of the fragmented environmental framework which I outlined above, and I think the ability to decline marine consents is probably the most important change that has occurred. Thank you.